let me take you back in time a little bit. The good old days. Okay, we learned how to find height of a triangle. The height is often right across the triangle, but you don't want to think of it at first. You might have to solve some sides on the outside of that triangle before you zoom in. Okay, we learned how to do that. We sliced it up. So this is page 28, in case you're wondering, where am I? Page 28, we sliced it up, and we ended up either way, either you slice it and use the left triangle or the right triangle, you're able to use that height, which we found is 4.3 regardless. Okay, so that's what we did. What was it, last Friday? I think I ended up with this last Friday on finding the height. And yesterday we talked about complementary versus supplementary. This is on page 32 if you're following. Okay, and I had some questions like, when do you know it's complementary? When do you know it's supplementary? Complementary, you kind of, I don't know if you see it, but you should see the dashed line meeting this base here at a 90, right? You should think of a corner. So if anything cuts that corner, what do you guess? You have a 90 there, right? 90 degrees. So you got to have some kind of corner or a T or something like that. Let's go up here on page 32 and I'll just give you a diagram, right? If you have something like that, complementary, 90. Supplementary, guess what? You're going to have some sort of straight line, and a slanted side is going to cut that 180 in pieces, right? So if you know that this is 50, right, you're like, oh, it's along a straight line, so that means that this is 130. So those two angles are supplementary. That property helps us. If you don't know one, you can easily find it just by knowing it's along a straight line. So supplementary, look for a straight line. Where's my highlighter that I use for this one? So supplementary, this is on page 32. You're looking for that straight angle. And when it comes to complementary, you're looking for, right, a corner of some sort. So it will be quite obvious on the diagram. It's not like it's going to be like out of nowhere, or randomly I take 180. No, it's 180 when there's a straight line of some sort. Okay? So we have that going. Go ahead. So we're going to go to page 35 now. 35. So I'm reviewing a lot of stuff here. I'm reviewing 3-letter angle notation, how to find the height, supplementary angles, all of that stuff in one shot, right? Yeah. So angle fun, where is that? F-U-N. Good thing I should say it a little faster, right? This kind of sounds a little sketchy there. Anyways, some of you know what I'm talking about, yeah? You're paying attention. Okay, so if this is 50, do this here. It's half of a circle, isn't it? 360, 180, right? So if this is 50, then this angle right here, I'm going to highlight that. Oh, maybe I should do this, right? See that straight line? And I should use orange for the angle. This is angle fun right here. And that's the one. That's the one they want. And it is really just 180 minus the 50. So if you want to show that, it's 130 degrees, right? That's what we want. So we're going to write that in. 130 degrees, which I did see a lot of you do. All right. So now you have an angle inside the triangle. Bingo. That's worth a mark, by the way. If you wanted this on an AC or quiz or test, even on the exam, that would have been worth a mark. Just finding that. Next is the distance between the dish and the plane. So you want to call it lowercase u. You want to call this x. It's up to you. I'm going to call this x, right? Side x. What kind of triangle do you have here? What scenario? Sorry, I should say what scenario? Side, angle, side, right? You got the two sides and the angle squished between. Okay, so it's side angle side, cosine law. And the way you solve that is you say, okay, the side that I'm trying to find, and you go 1.86 squared plus 2.75 squared minus 2 times 1.86 times 2.75 times cosine of 130. Okay, there you go. Next line will be making sure we square root whatever this ends up being, because we don't want x squared, we just want x, and so we need to square root for that. I don't have the key in front of me, so I'm going to have to do this with you here. So if you're able to type this in, oops, numbers will not be very big because you're using smaller values, right? So that's 17.597, and that keeps going. I'm going to take the square root of that. That's 4.19. Does the answer make sense? It's the largest angle here. The longest side across from it, it checks out. And it checks out. So there we go. Question? Okay, remind me. What's the angle of elevation between the ground and the Tish's line of sight? This is a key word here. Angle of elevation between the ground and the Tish's line of sight. It's asking for this one right here. Angle of elevation is always measured with the ground and your line of sight going up. So that's what they're asking for. It's angle N, correct? That's what they're asking for. How do you find it? You choose. You want to use sine law? You want to use cosine law? It's up to you. What do you want to use? Any votes? I have no key on me, so it doesn't matter. Sine law? Cosine? Sure. Let's do cosine law. And those of you that have sine law, you'll check and it'll be the same or very close. So if I want n, then I got to go cosine of n, add, subtract, right? That's the pattern. The side across from n is 1.86, square it. 2.75 squared. I know the other side, it's 4.19 squared. And then I go 2 times 2.75 times 4.19. Let's figure out what we get. And I encourage you to follow along with your calculators. It helps. 21,659. And the denominator, 23,045. Angle N is going to be found by going cosine inverse of 21.659 divided by 23.045. And if you're wondering why I do the brackets, because you're taking the inverse of that, so it's best to do it that way. Shift cos 19.97 degrees. You round to 2 decimals, regardless of what your teachers did last year. Okay. Sure. Last one. Last one. The height. I'm going to use a different color. What did I not use? Green. Can I use green? Calculate the height. The height of this, the plane above ground. Pay close attention to this part. I'm going to go back up. And I'm going to insert the height here. It's kind of hard to see, but the height from the plane, it would be measured straight down like this. And you know what? I'm going to erase this. And what angle is formed between the height and the ground? It's always 90. Okay. So you put a little box there. We're going to cut that one out, bring it down with us. Okay, so bring it down here. I'm going to sketch it in a, it's clear like this. This is how we're going to sketch it. This is our height. This is the plane. This F for us in the diagram. This is U here. The 50 goes here. That's where the 50 had been originally. Do I know this side here? If you look at your diagram, what's that? That's 1.86 miles. Okay, so I copied that. I'm going to highlight this green here. And I'm also going to go up to my original diagram where I drew that dashed line. I'm going to do the same thing there so you know where I got this from. So now, do we have a pair? Yes, we do, right? So you go sine of 90 over 1.86. Remember, sine law doesn't go anywhere. It stays with us. Sine 50 over h. And so now we're using sine law. So we go cross multiply and divide. 1.86 times sine of 50 divided by sine of 90. Sine of 90 is just 1, right? Sine of 90 is 1. So we're not going to bother dividing by 1. But that's 1.42 miles. That's how high above the ground the plane is flying. So this is basically a remix, right, of everything we've done so far. We used some cosine law, sine law, you name it. Okay. By the way, those that use sine law for C, what did you get? 1980? 88? Okay, it's okay. And that's unfortunately because we would need more decimals on our side lengths to have the same. We're good? Questions? Remember, you're smarter than you think. Whenever you think like, oh, I can't do this, like sit down, right? When we design questions, we have whatever in mind, whatever we taught, we have that in mind, right? So you just apply that. Okay, so I'm gonna pause this, or I'm gonna